There. Oh, good. No.
Did you? I'm. Can you hear me? Ooh, okay, great. Okay. So, like I said, please interrupt if you have questions, and we can talk through it. So, I'm fairly friendly. I might make some jokes, and I can hear myself in that laptop. That's okay. Okay. So, who the heck am I? Um, I'm a guy that's worked in about 14 companies so far, everywhere from embedded software to cloud services to now infra as code systems through Google and Riot Games and VMware. And if you've heard of ChainGuard, I was one of the founders. And currently I'm working at LinkedIn on trying to help them take their graph technology and turn it into something that's actually cloud ready. We call it cloud native. Uh, and before during the end of my Google time, I was working on Knative, and I'll show you a little bit of Knative. And through that, I was also working on cloud events. I have several talks on at the CNCF KubeCons. I've been to Europe a few times. I went to China once. It was very fun. Okay, so that's who I am, and this is a graphic that I had a friend make for me. I did a talk on. If you search for polymorphic reconcilers, you can find a talk, and we themed it as the Untitled Goose Game, because if you think about that game, if you know the game I'm talking about with the goose that's like stealing stuff, well, the NPCs actually are reconcilers, and they go and fix the world back to whatever they think it should be, which I thought was really cute tie-in with Kubernetes. Um, because I was told that some people don't know what Kubernetes is, I thought I'd do a brief history of how the heck we got here. And so here's the way I like to talk about this story is uh, back in the day, we would spin up a server and we'd run an application or several applications on it. And it it was really difficult to manage making sure that app A and app B didn't kind of destroy each other. And ultimately, our servers cost money, and we would like to get as much app usage out of our servers as possible, right? So we start stacking apps together, and all of a sudden it gets to be chaos, right? And if you've ever used Ruby in production, circa 10 years ago, and the little global package manager would install some random thing on top of everyone else, and everything would break, you got to be real sad. So people uh, right. So you do this, several times across the globe on your global service, and all of a sudden you have 50 installations and you have 50 unique custom installations because everything is Snowflake, right? Everything is very unique to that specific purpose, and it has this life and history, and you have to basically have a document. It's like what happened to this particular server, and it's terrible. So somebody said, you know what? Maybe what we should do is we can contain the OS and the file system, and then run our applications inside a smaller fake computer, and we can start to pack stuff together a little tightly. We can get away from Snowflake hardware and Snowflake applications, and this is okay, but it's pretty heavyweight if you're trying to ship a VM to the Philippines. So the VM again, it has the base image or the base OS and some other things, but it's still very heavy. It's a heavyweight thing to try to leverage and use. So fast forward, and some of the improvements that Google made, and actually Martin was around to see some of these actually happen at Google, where sandboxing for applications became more commonplace, which led to the development of things like containers. So now we can strip out the OS from the concept of our application and the little file system, and some of the heavier weight stuff that we need to run things gets to be co-located on the host, and we start packing things a little tighter, right? So now we get to a lot more apps running with the same utilization because there's less waste, there's less overhead between each piece. So this is really nice, but you run into other problems when you all of a sudden have all these containers, right? It gets really hard to manage all this pile of containers because you probably you want multiple instances of the same container. You want if you're familiar with microservices, they work best if you have 1,000 of them, but it's really hard to manage 1,000 things in production. So that leads us to Kubernetes, right? So I hope that arc kind of gels with everyone's understanding of compute. Anyone have a fight about it? No. Okay, so this talk is not about Kubernetes in how do you run applications on the compute abstraction, but I want to talk about it just to understand how Kubernetes allowed us to think about declarative APIs and some of the compute abstraction, because it'll make sense later. So we're starting the world of, we have a lot of containers and we need to figure out how to schedule them, and they're going to crash all the time, and we need something to bring them back. We need something to do rolling updates, and all of that stuff is hard. And Kubernetes attempts to make some of that just a little easier for us. We can start with some terms. The Kubernetes API server, otherwise I will usually say the API server for the rest of the talk. That is, sometimes people think of it as this big scary thing, but it's really just a REST service that's implemented inside of Kubernetes. That's really all it is. It's just REST, it's JSON, it's YAML, speaking over a CRUD interface. A resource is the thing that's being represented, right? It's the R in URL or URN. It's the entity. And resources have 3 common fields inside them. They have a very common shape. So they have metadata, which tells us about their types. They have spec, which tells us what we think it should be doing, and status, which is what it thinks it's doing, which could be completely different. And the spec status thing allows us to introduce this new concept of the declarative API, where what I've asked you to do is different from what you are actually doing. And I think, yeah, okay, later. Yeah. So if you, and there's other resources, and I'm not going to talk about them all, but the core resource is called this pod. And the pod concept is co-located containers with some extra wrappers around them. And the entire job of that thing is to run the container and, you know, ask it for probes and other things to make sure your software is running. You know, are you on the right port, or can you do port mappings? And that's where its responsibility ends. It says, is this container running? And then there's a bunch of other things around it that help it do its job correctly. So the blue boxes, the replica set and the stateful set are similar, but replica set says, basically, I would like 5 of these, please. And its entire job is just to make sure that there are 5 pods with the template inside of its spec that make sure they're running in production, which is really cool because it takes your 80% uptime application and it turns it into a 95% uptime application. And then a deployment, and then the stateful set is, I have a stateful thing that actually, the replicas from the replica set all are the same thing. There's nothing that's more important about any of them at a time. But the stateful set, you actually might want to have an ordered set of things. So like a database with lead and follower, for example. The replica set just makes sure that there's 5 pods or 10 pods running in the cluster. And if it counts 7, it terms 2. If it counts 3, it creates 2 more, right? And so on, forever. Deployments help you create other replica sets, and it lets you ramp from one version of your template to the next version. That's kind of at the very basic level. That's really all it is. So now, okay, so we're going to go back down that stack, right? So we have version 1 of our application that's running, and we have version 2 that's running, and we want to get to version 2. the deployment's job will be to ramp those replica sets from one size to the next. The replica set, because it's constantly re-engaging with how many replicas it's been told to have, its job is very simple. It just says, oh, I have too many pods. Let me fix the number to be closer to what I've been told. So you get this composition up the resource chain, and you get to be very focused about the particular job this slice of your model is doing. Services are how pods are exposed to the internet or exposed to the network. So it could be internal or external, and load balanced. And config maps and secrets are similar. Secrets are pretend encrypted. They're base64 encoded, but there's other plugins you can do. You probably are using like a HashiCorp Vault service that stores your keys off, and then the secret is actually just a pointer to something that's encrypted, and it comes and gets mounted. Config maps can be projected into the volume as files or as environment variables, and I think the same for secrets, but maybe that, yeah, maybe it's just files for secrets. Yeah. Okay. So that's the resource model of Kubernetes that I really want to talk about. The thing that I think is interesting about Kubernetes is, so all of this stuff and most of what everyone's probably talked to you about Kubernetes before is these resources help you do compute abstractions, and they let you make big clusters and schedule your workloads in the data center. And now instead of having to deal with these pile of VMs, you deal in this cluster and things are scheduled where there's space rather than you selecting, right? That's the declarative piece. It's you peanut butter all of the Kubernetes across your data center, and now you can take advantage, and you basically give control to the Kubernetes operating system, and it finds spaces for pods to exist in production. That's right. You
wait with that microphone. So where you? Okay.
Speak louder.
No, you cannot, because people online will not hear you.
No problem. So you
No, have to use the microphone.
okay.
It's not so hard.
Okay, I will do it. So you abstract the infrastructure and then you abstract the application.
That's right.
You're happy with the response? Okay, thank you.
So that's that abstraction of the application and infrastructure. People usually call that a container orchestration platform, right? So that helps you make use of all of these wacky computers that look similar or maybe very different. And it's up to each individual host that's running containers to tell the rest of the Kubernetes schedulers. I don't really care about those details. That's not the piece that's interesting to me about Kubernetes, but it is a useful thing, right? The second thing that Kubernetes did is about 5 years ago, CRDs were introduced, custom resource definitions. And what that let you do is expand what the Kubernetes API provided to you through the standard REST interface to be your own API, but it looked native to every other client. And you can do some really interesting things here. And I like, so I said that I was an embedded developer originally, like almost 2 decades ago. I started out as writing software for hardware, and this is a hard job for a lot of people to understand because sometimes you're waiting for a pin to lift and then you execute some code, right? That style of programming, it looks a lot like event-driven development too, right? So so that model, it's also called async programming. It's interesting and it's needed as a concept when you're thinking about custom resource definitions, and we'll talk about that soon. So this declarative API thing is cool because it's the It's the table for two, please, when you go to a restaurant. You don't say, please give me that table over there in the corner by the bathroom with 2 plates and 2 forks and a tablecloth, please. Because you delegate the request for a table for 2 to the waitress or waiter that takes you to your table. And depending on where you go, the table looks dramatically different. So that's the declarative piece. And we have declarative things in our house with, well, maybe not in Sweden because it's really hot, but you have thermostats in the United States where, it's taking a probe of the temperature in the house, and as soon as the house is too cold, it heats it up, turns on the heater. If it's too hot, maybe it turns the AC on. Okay, so the custom resource definition is the thing that we can use in Kubernetes to create these declarative APIs, which allows you to move your certain types of workloads into a declarative API shift, and it's no longer these imperative sysop commands. If you're using Terraform today, there's a bit of Terraform, right? Like the interface between your Terraform module and what it's doing is usually declarative, and then what Terraform is doing to the rest of the infrastructure is imperative most of the time. And there's other examples. Okay, everybody following so far? Not too wacky. Okay, so CRDs came on the scene, and Brian Grant coined this new term called Kubernetes resource modeling. What that is a fancy way of saying, what if we made APIs that looked exactly like what the API server serves for our CRDs that get installed, so the actual REST interface, and we define that as a standard. And the standard is the Kubernetes resource part, right? So everything has metadata, spec, and status, and how we assemble the URLs for the CRUD interface become part of the expected behavior of trying to serve this request. So it means that everything has this known shape at the start, but of course, the spec can be custom and the status can be custom, but they have a base shape that's similar among everything else. So metadata is mostly static stuff, like what's the type, where does it come from, what's the version, what name does it have, what namespace does it have, and then you can do other things like label or annotate it that let you, actually, fun fact, does anyone know what the difference between a label and an annotation is? Okay. The answer is they're the same, except labels are indexed, and that's really it. So you can ask, let me step one back. One of the interesting, innovative things of the API server, and it's also very expensive, is that it supports something called watch. And watch is an API call that allows you to ask it, if this thing or this kind of query changes, can you send me the results back? And it's expensive because, well, most databases don't do this unless you have to you install some kind of extra hooks in the database. But the reason Kubernetes can do this is because this thing called etcd, which is the database, and etcd, when it started, was actually based on a file system. So originally what it was doing and why it had such limitations was it was just setting up a file system watch. And when that changed, it would send a hook down, and bingo bongo, you got events, right? Okay. So we're back. So the common shape of things. Metadata. What is this thing we're talking about? Spec is the declarative API part. I would like you to eventually be like this, table for two. And status is the table you got. So the spec is the ask and the status is the reality. And you might, sometimes when you ask table for two, you don't get a table, you get sent to the waiting room. and that could happen in Kubernetes too. So if you remember the Kubernetes resource layering, I'm gonna steal Patrick's lasagna. Anyway, sorry. So you could think of this thing as there's a deployment and you have a replica set and it's phasing, it's ramping from 10 to 1 and 8 to 2 and so on. And then the final thing are maybe an individual pod. Well, it would be really nice to know if there was a major failure or something interesting in the status of a pod that's a couple layers down. But the way that actually tends to flow in Kubernetes and when you model things is if deployments make replica sets and replica sets make pods, pods never interact with deployments directly. They always flow information through each intermediate resource. And so you get to filter and choose what's important and maybe reinterpret what the pod is saying at the replica set level, and then tell the deployment, this is the information that the operator, meaning the human, actually needs to know to be able to make progress. With funny shapes. Right, so we talked about this a little bit. The API server is that central API, fixed API server. So I'm introducing a new term now, and that's a controller. And you might be confused because you've probably heard of operators and controllers and reconcilers. They all kind of mean the same thing. And my personal how I define all of those things is a controller holds one or more reconcilers. A reconciler actually operates on a single Kubernetes kind, and an operator is a marketing term made by CoreOS. And what they mean is controller. What are you saying over there? Okay. Wow, that's a bad slide. Oh yeah, okay. The reason for this slide is what happens when you actually talk to the API server for one of these requests, right? Remember, it's a CRUD server, so if you do create, this is the list of things that happens every time for almost every operation. And I think I have a better picture. No, I don't. I had a better picture, but I trimmed it down because this talk is meant to be shorter than I basically combined about 6 hours of material into this hour and a half. So here we go. But the thing that's interesting here is that there's hooks at each of these levels to be able to go and change what it's doing. And actually, I think I do have a slide. Hold on 1 second. Don't look. Stop looking. Are you looking? Stop looking. Yeah, okay. Okay, yeah, we're going to talk about that more later. But just realize that there's this whole flow of things that happen every time you interact with the API server. And when you're using custom resource definitions, you get a chance to hook into the flows of that. Actually, you can hook into the flow of that for any other kind on the API server too, because the request, I didn't show it in my resource model, but there's another resource that defines the opportunity to add an opinion into this flow. So people call, well, you'll hear that called, or if you want to search for it, it's mutating webhooks or admission control, things like that. So this, when you're making those resources, what you're actually doing is registering the ask in this flow, please go call that thing and change the opinion and change the flow here. So everyone is asleep? Okay, so I thought it'd be interesting to go and look at Knative, not because I'm trying to pitch it to you, but because it's an interesting and well-developed implementation of customizing Kubernetes, and it uses Kubernetes resource definitions to expand the API and do some new thing. And it happens to, serving is something like this, where it tries to give this new service object, and the goal is containerized serverless scaling, right? So it's really hard to do a scale to zero, scale real big service inside of Kubernetes because you need to know a lot of topics. There's a whole bunch of things you have to get right to be able to actually scale something automatically. And you can do it, but it's hard, right? There's a bunch of projects that try to help you, but I think Knative is probably the most mature one, and I happen to work on it. And it looks kind of like this, right? So the spec piece is, well, we actually made it look a lot like a deployment. That's why the shape kind of is similar. And we made it so that you don't have to specify too much. So the service is the outer wrapper. It's the thing that you tend to interact with, and it looks like a deployment. But what it's actually doing inside is managing this configuration object, which is the desired state of your application. So it's basically pointing to the revision that you want to use. And unlike a deployment, you can actually do traffic splitting and other things with Knative. So you can roll your app out, and you could even dark launch it. And if it's not, so every time you change the service, you're making a new revision, and the configuration and the route are helping you do traffic splitting and dark launches and rollbacks and that kind of stuff. And deployments let you do that sort of too, but the deployment is more about, I had A and I want to move to B, and I actually made a mistake, so I'll go back to A. And Knative is more like, I had A, and now I have B, and I also have C, and I have D, and I'm going to split 25% across everything. And you can't do that with deployment. The internals of service, not actually that important. And I'm sorry, they did call it a service. The first thing I did when I joined the project was I said, hey, that's a bad name. Maybe we should call it something else. And it was even worse because Knative, when we launched it, and I joined the project a little before we open sourced, it was supposed to be called native, and the K was going to be silent. And I was like, so we're going to have this service object, and I don't know how to ask if it's the native built-in service or the native service. Wow, come on. Okay, so I thought I would show you a little bit of. So I have this Go program. Well, simple thing. It's a hello world, simple, something simple, right? Based on an environment variable, it's just going to echo back hello and then whatever the thing is. Not that interesting, but we're gonna make it work with this, right? This is a deployment and service, and so. Oh, I forgot. I'm gonna teach you one more thing. There's one thing looks odd in this thing, and that's the image. So I don't have a Docker file because I don't actually know how to make Docker files. They're too hard, and I've never learned how to do that. But because I'm a Go programmer, I can use this program called Co, which you can find it at co.build. It is a kick-ass program that takes well, actually, here, I'll start. So you can say go run and then local, because it's gonna this directory is executable, and it's gonna spin up a web service, and now we can curl. I can type, so I can get a hello world, and if I sent it to environment variables, I could change it. So now I can say co-apply this Kubernetes YAML, and what's going to happen is it's going to look for that special scheme of co, and if it's local to the Go module and executable, it's going to build the binary and smush it into a container and then upload it to the registry, and then string replace this is the new container we just built. or well, it's this too. So it's gone up to GCR because I'm using GKE right now, and it created that same template that came in, but it string replaced it before it kind of piped that file into kubectl apply. Or yeah, so really cool tool. You can also, oh, here, I'll show you. I'll just show you. I think it's resolve. So we can say co-resolve, and it's going to do the same thing, except instead of pushing it to kubectl, it's going to squirt it out onto standard out. So you can dev loop with co using co-apply, and then if you want to release that as the manifest artifact, you can co-resolve, and it sets up the template, and we can verify that, right? So there's the image replaced. Anyway, so that was an aside because I was trying to buy time waiting for IP address. We will get. So we have this hello Kate's, and we can grab this thing, and we can give it 8080, and it'll and forget some zeros, and how do you use SNUS? So there we go, right? So that's cool. Let's make it work as a Knative service in place, right? Well, not in place, but you'll get it. You'll see. Everyone can see this piece, and I have it backed up just in case we screw this up, but we're not going to screw it up. Just to make it easy, I'm going to call it hello, and I don't need that. I don't need that. I don't need that. I don't need that. We need that. Knative defaults to 8080. Actually, you probably shouldn't even pick it. We don't need this. So this is what a Knative service does. And remember, the goal is to make Kubernetes easier to use, and it delegates to making deployments and managing services all for yourself. And so one of the pain in the butt pieces of trying to be to work with Kubernetes is, well, especially deployments, is you have to make sure that that label selector actually gets into the template and the service, and you don't accidentally select other applications, and it gets really hard to debug because it'll round robin through a bunch of random unrelated applications, and you're like, what are you doing? And I've definitely done that. So there we go, right? Pretty reasonable to understand, and now we just have to make a Docker file. Just kidding. So I changed the name of the thing, so it should work out. Yep, I do.
I just asked them to change the kind of the deployment.
I'm going to cheat and just grab this. It's not staged. It totally is. I don't know why this looks wrong. Oh no, it's the container. Okay, we're good. And there's a double check. It's just flipped. Cool. Okay, so we're gonna beep bop boop our container. Good. And so now it's ready. And ahead of time, I set the cluster up with Knative. I had to install it, and you have to pick a gateway. I am using, I think, Contour here, and I also set it up with a domain name. So by default, the service name that we created, the Knative service, I'm sorry, the native service, no, and the namespace are part of the URL. There's an extension that's in beta in Knative that lets you do custom domain mapping, which is really cool because all of your Knative services can be cluster local, and then if you make a domain name attached to it, then it exposes it, and you don't have to be bound by the namespace name rule. It's very useful. It's probably a better pattern. But just to prove that it actually works, we can curl this thing. And just for fun, I also screwing around with something like this. But I said it's scaled to 0, right? And so we're going to get the pods, which is the interesting piece. I kind of over here. I want you. So if we wait 2 more seconds, the hello pods should start terminating, which, because we're not using it, right? And one of the cool things with Knative is that I like to write tools to help me understand what the heck is happening in my cluster. And it doesn't make sense for me to pay a pod for that tool to live indefinitely. But I can install them in my clusters. And then when I need them, I ask, I spin the website up and it becomes available for me, which is, I think, a really useful pattern. And I like to pitch Knative as the airplane or the airline model, where you over provision the number of seats, and then most of the time you bank on not everyone making the flight. So so it's terminating now, and we are going to try to break my computer by doing you lost the copy. And so we're going to do this for a couple seconds, and back to here. Yeah. So now, like, a whole bunch of pods are getting created and started, and if we wait 90 more seconds, they'll all go back to 0, and it's pretty cool, right? I don't know if it'll schedule all of them because it's not a very big cluster, and I just asked it to do a lot of work. So, okay. So that's Knative in. There's other features that I could show, but there's other talks that you can see them. But to prove that it scales, I thought I'd send that for you. What should I? Oh, okay. Actually, before we continue, so Knative made us a bunch of resources on our behalf, and so I showed you the little box with the other stuff inside, and to prove that it's real, right? So we have the service that we created, and the service created these revision routes and configurations. And if I go and interact with the service, it'll make other things. I could show you that. So let's make it say something more different. I don't know. Oh, wrong. We'll just lean on co. That was great. And then if we get the group or the Knative resources, we see that there's now a new revision, and if there's other talks that show you can basically manipulate what you're asking for in the service to be able to flip back and forth between version 1 and version 2, or you can give them special names, or you can give them traffic splitting, or you could dark launch 2 and say, I would like to put that in production and then test my code out, and then once I'm sure, I can switch the configuration, et cetera, et cetera. It's all cool, but it's the point here is that we're talking about extending the resources you have available to you to be able to make Kubernetes more useful for your actual use case. And this is a very particular example, but you could make it your own, is my hope. Okay. Okay, so now we're going to talk about CRDs. Okay, so we talked a little bit. And the thing I guess, so we talked about CRDs and how it's an extension to the API server. And then we talked about Kubernetes resource modeling, where there's like this common expected shape. And I just showed you Knative. And if you ever heard about Cloud Run from Google, it's a scale to 0, scale real big container service. Sound familiar? It's actually, I can take the Knative serving spec and give that to Cloud Run, because Knative and Cloud Run are partners, or they used to be when we first created the project. And the idea was that you could define a serverless compute ask, and then we could create a completely different implementation, because it's more efficient for Google to run your container in a serverless, scaled real big way, not using Kubernetes if you don't need the cluster. So the Google Cloud Run is actually the ideas of Knative implemented as a KRM, right? So it's just the APIs, and it's the expectations behind the APIs you define, which is the hope was that all of the other vendors would also implement these APIs, and no one would ever say the word Lambda again, right? And it's better for people, because if you start using Cloud Run and you love it, and then you want to bring your code on-prem, well, you just install Knative, this open source reference implementation, and it's not as good, maybe, because it's running Kubernetes and it doesn't have, the fancy Google infrastructure, but it's going to work, and it's going to work on your laptop, and it's going to work in IBM Cloud or whatever that is. So that was the hope, right? And so the aim of what I'm trying to talk about is Kubernetes is really great. Declarative APIs are really great. KRM is the thing we actually want to talk about, and CRDs are how we get it done. Okay. So the point here is that Kubernetes is not required to talk about Kubernetes resource modeling, but it sure speeds the process up, because you have a place to actually build stuff. And I thought I deleted that. Anyway, okay, so we had I borrowed these slides from a different presentation. It was Batman themed. But okay, so we talked about how, it's the API server is just a REST service, right? And that metadata about, the kind and the API and the version and the group and the namespace and the name, they all get assembled up into a URL that describe that particular resource through the API server and eventually stored in etcd with some magic, right? So we're going to define some terms again. We've talked about resource. We talked about CRD. Custom resource or custom object are kind of, they mean the same thing. It's the instance of the CRD, right? So Knative defines a Knative service, but I defined hello, which happens to be an instance of a Knative service. The kind is the object type. And there's two kinds of scope. There's namespaced, which means the object lives in a namespace and it has usually limited visibility. And then there's global. And these things tend to be prefixed with cluster, blah, 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 like cluster role or cluster binding. And then a webhook is something that expands on that API flow. When you do a create through the API server, it's going through a series of steps. You could install a webhook that goes and does some other opinion and returns back. So webhooks are how Kubernetes decided to do extensions, and maybe Martin knows a little bit more about why, but it's actually really handy because you can change how Kubernetes works without recompiling it. And that's really great unless you're a kernel nerd, and then it sucks. Okay. So I've talked a lot about resources and CRDs and custom resource definitions and KRM. And it turns out that the way Kubernetes implemented custom resource definitions is as a resource. Shocking. So if you look at the resource, it has all the same shape. So it has the API version and kind, it has metadata, it has spec, it has status, but I don't show it here. The status is useful if you create the document and you have an error, or the API server gets confused, or something conflicts, it'll show you a status and you can go and fix it. Sometimes you'll create a resource, a custom. Sorry, you'll create a CRD, an instance of a definition of a resource, and you will make some mistake, and the old one has been accepted and the new one is rejected, and the only way to really know for sure is to look in the status of the instance of the CRD. So one thing that might trip some people up is that there can be multiple versions of your resource inside of Kubernetes, and there's these two things called served and storage, served and storage, which means served means it's okay for the API server to actually return that as an ask when you're doing those CRUD interfaces. So it's a valid endpoint to go and ask for. And stored means it's how, when we make a new resource, that's what goes into the database as that version. And you can have many, many versions, but only one should be stored, which doesn't mean that it's the only thing in the database. It just means that's the only one for new resources, and every update should be that version. And just talk about that. And the other thing is you can have this open API document that talks about the structural shape of your resource. And these are all hints for validating on how the resource should be processed, but also for other upstream integrations to use this thing as the client generator. So you saw me do kubectl get k SVC. Well, it was actually in the Knative service. It's defined as a short name of k SVC. So that's how that magic was happening. And that's also how, when I did kubectl get Knative, there is a category, which I don't show you in this, but we defined Knative as a category of a bunch of resources that show up in that list. So if you are making a bunch of CRDs in your company and you would like to quickly look at them all, you can start looking at categories and short names and things like that. Super handy. We had to implement it because, well, the short name for a Knative service, it was, well, if we didn't define a short name, it would be kubectl get service, and that doesn't really work because there's already a service. So, and then all of this stuff, these hints and the metadata and stuff turn into stable APIs to talk about that resource. And here's some examples. And more examples. Okay. So this is what I looked ahead in the presentation for. So we have the magic, and we're going to talk about the magic now. And so here's a prettier version of that big list, right? We have authentication, meaning do you have the keys to actually talk to me? Okay, cool, you do. And then authorization is, do you actually have the authority to do what you're asking to do? And in Kubernetes, this is RBAC, roles and role bindings. But there's actually a webhook you can register to implement your own custom weird logic. So if you only want to have people create resources between 8 a.m. and 5 p.m., you could actually set it up to reject all of that. Or if you don't want to make changes on Friday, you could set a access review and you could reject all the things. You could do whatever you want, which is kind of the point. So once you get past the I am who I say I am, and I can do what I say I want to do, we get into these. You can do defaulting, and the structural schema that I showed, you can actually add defaults and other things inside there. So if there's a default defined in the structural schema, it'll actually default the resource on its way through this chain. Or you could define another resource called a mutating webhook configuration, and that'll call a webhook. It basically gets the resource and says, this is the verb that's happening to this resource. What do you want to do about it? And maybe you can write some custom logic to mutate that thing and return it back. And then once all of that business happens, it goes into validation, which you can, in Open API, you can put validation parameters and things like that, but it's not actually, there's occasionally things that you, logic that you can't encode in that, or it's too complicated, and you can write your own webhook, right? And so you can write your own custom wacky validation logic. No making, yes.
Thank you. Great presentation. The question about is authorization. There was a new kid on the block called Open Policy Agent. But I understand there is a competitor in the Kubernetes scope as well.
I think so. Open Policy Agent. Well, let's see. Most of the time, I've heard it on the. I have an interesting problem, or I want to be able to write filters for requests in some sort of bigger, complicated way, or I want to be able to write some very demanding logic in their OPA language, and how it's integrating is in these webhooks. So it's the policy agent is, it's not necessarily a competitor, but it's an extension of the built-in mechanisms that already exist. So it's Kubernetes is it's this like the base layer, but it's really difficult and it's really verbose. I was speaking Swedish, sorry. And so, you know, there's applications like that that bring higher order power logic into the ecosystem, and rather than be competing with it, it actually just it expands it, and that's part of the ecosystem and is expected. So it's like Open Policy Agent is giving you more power to do more challenging things that you could already do today, but you just don't have the time in the day to implement it all yourself. And so just like Knative that you want to do scale to 0, you delegate down to some other piece to expand some capability that you would like to do. Yeah.
Yeah, I mean the point is that you know, I often say that Kubernetes is you know, like assembly language for building infrastructure. And you know, if you add something like Open Policy Agent, you don't have to write your policies in assembly language. You can actually write them in some higher level thing, right? And so everything about Kubernetes is that way. I mean, you add Knative, you don't no longer have to, you know, write your stateless services, you know, in assembly language. You sort of do it with Knative, and it makes it a lot easier.
Oh, thank you. And then, oh, sorry.
Yeah, for one of the beauties with OPA, that you decouple your policy from the enforcement, and you can test that outside the scope.
Yeah, oh, yeah, absolutely.
And you can imagine if you set up a policy, you are just allowed to Sundays. If you have a Jira ticket and your name is Hans, that is a nightmare for proving for an auditor.
Absolutely.
Comply.
And you can apply to you know, messages or event creation or resource creation or HTTP requests, and yeah, it's a cool thing. Thank you. And then I go through you know, just like writing a resource, so creating something down to the etcd, reading something's kind of, there's it basically goes through the same flow, but in reverse. And the thing that I actually want to talk about is when you're writing CRDs and you're switching between versions, there's a new one which didn't get formatted correctly, but it's a conversion. You can make conversion webhooks. There's a couple different ways to do it, and the common one that I've used is you make another webhook because I had the framework to do it, and it basically, the webhook gets you're asking for version 2, but I have version 1. How do I do this? And so you can write code that helps yourself convert this to that. And sometimes you have to be a little funny, or you might throw some data into the annotations and be able to pull them back out. And this conversion happens on reading and writing too, if there's multiple versions, or the version that's stored doesn't match the thing that the client is asking for. So it gets complex, but it is available, and it's not that hard once you write some unit tests to actually test your conversion between the two. Unfortunately, there's not great support in the ecosystem to help you write conversion webhooks unless you're using Knative's web framework, which isn't well documented. So there's really no help. So sorry. But it is there, and this is I think one of the things that's hard for people when they're first starting to think about writing CRDs is that they don't really understand this particular flow, and they don't think about it as a chain of steps that's always happening, and it's really just a call to a webhook that has a specific role, and it comes back, and now you have the object, and you come back down, and now the new version gets defaulted and comes back, and then it goes to validating, and it comes back, and that happens all the time. That's why they have to be fast. Right. Okay. So talking about version conventions. So usually things start at alpha. So V1 alpha 1, and you can have V1 alpha 2 or 3 or 4. The V1 alpha means that it's unstable and it might break, and to upgrade between versions, you might have to delete your cluster or delete all the resources. I give no guarantees, right? And then once the API gets to beta, then there's this best effort conversion policy. It's probably best if you're providing the service to practice the conversion webhooks, because they are a bit cumbersome, and build the muscles before you get to V1 so that you know pretty well that it is actually going to work. But you're attempting to make no breaking changes. You're attempting to do additive APIs. Upgrades might need some help, right? And then once you get to V1, then this thing is supposed to be stable, and it doesn't mean that it's finished. It just means that next time there's a new feature, well, you have to be able to default that next field, or else you have to move to V2. So if you can't default it, then you start the process over, V2 alpha 1, and so on. And I just want to point out the stored. This is not the full object, but the versions, they tell you what's served and stored, and that's what you can interact with. And then if you look at the status, it'll tell you what's stored, what is accepted, and how it's going to be saved to the database. Okay, so that was a run through CRDs, right? So now we can definitely make CRDs. But that's only half the story, right? The other half of declarative APIs and KRM is that we can define these nice, easy to interact with APIs. And then the other half of the story is that there is a always running reconciler that's taking your status and then looking at the world, thermostat style, and saying, well, it's not exactly what this says, so I'm going to do some work, and I'm going to let the human operator know what happened. So that's the job of the reconciler. And the way it does this mechanism is, I think we built it up. No, I shortened it. Okay. So reconcilers are just code, right? And then you can have multiple reconcilers in a controller. The controller is the thing that helps you, when this container boots up, it's going to get some credentials to the API server, and so it needs the keys to talk to the Kubernetes. And it'd be really great if I had more than one reconciler to use the same client. So the controller's job is to make sure that when I create clients and caches, the client is just the REST interface. It's just a structured way to talk the REST to the API server. The listers are a interaction using the client to be able to do gets and lists, but not through the API server, through the cache that's been populated locally to the cluster. Because it'd be really expensive if every time you wanted to reconcile something, you would have to go reach out to the API server and all the way back. So it'd be really nice if there was this thing locally, and it would also be really nice if I had two reconcilers asking what the state of the world is, they actually see the same thing. So that's what the cache is, and that's what listers and informers are for. Actually, listers are to get the data. Informers are to, I talked about that watch. Well, the watch is actually, so I was teaching a bunch of people Kubernetes concepts, running through these decks and some other things, and I got called over, and it's like, hey, my controller only works for 5 minutes. What's going on? And I look at it, and they had called watch directly in the client, which, thinking about it, it's like, oh, of course you should call watch in the client. It's there. You're calling create and get and lists and stuff. I guess why wouldn't you think you could call watch? But you don't. You never call watch directly on the client because that's the job of the informer, because watches hang up, right? It's kind of this best effort. You call the API server and you say, I'm interested in changes to this kind. Please tell me about it. And it'll tell you for about 5 minutes. And then it'll hang up and say, I'm tired. I'm going to go take a nap. And then your job is to go and call it again. Be like, hey, I'm still interested in the changes. Remember that? And so that's what informers do, is they manage that connection with the API server and keeps watch streams open, and then updates the cache, and then events locally and says there was changes to this object, by the way, you might want to go check it out, which is what this little lightning bolt thing is. Well, anyway, so I think we've defined all of those. Again, here's a bunch of reconcilers, and you don't want 3 copies of the clients and the caches and the informers and the listers if you have 3 reconcilers, because again, you need to be able to make changes to the world and then have the world tell you what's updated, and then update that local cache, and so that everyone else can see the same thing that you're seeing. Otherwise, you might make different decisions about when to turn the thermostat on, right? So what happens? What causes that little lightning bolt? Well, it's when you basically, if you change the copy of the local cache object, there's a mechanism inside the informers, that's why they're called informers, to tell you, hey, I made a change, you should probably do something. And that change actually goes through this flow of code that puts a special string into a work queue, which is this little work queue box. So work queues in Kubernetes are all typed, and they have this interesting, they are typed, and the string inside them is usually the namespace / the name of the resource we're talking about. And the only way you know how to pull that resource out of the clients or the listers is to be able to take that string and split it and then go and make the right call and get the resource. The frustrating thing is that they're typed, and the only key that's inside the queue is the namespace / name, and it'd be really handy if it actually told you some other type information, but they don't. So when the informers are sending these signals and saying, hey, this thing changed, what's actually happening, and there's a bit of glue code that takes the change event and then strips out a bunch of metadata, drops the entire event, and just grabs the namespace and name and puts that key into the work queue, and then the reconciler has to check the state of the world, and it basically starts over again. So you can also do, and you should re-reconcile after time, right? It's like, funny story, the default time in the example in Kubernetes, in like upstream Kubernetes was 10 seconds was the default, and so we started testing Knative, and every 10 seconds every reconciler would re-reconcile every resource in the cluster, and we were trying to figure out how big this thing can get. And it turns out we broke the API server, and we were running into API quotas and all this other crazy stuff because every reconciler was just doing stuff as fast as possible. And so we eventually changed 10 seconds to 10 hours upstream so that other people don't run into the same problem. All right, so that work queue, right? So it's, like I said, it's typed and it's just a name and a namespace. Okay. I'm sorry, I do flows, right? So when a controller starts up, it gets some keys that get injected to it and creates the authenticated clients. And from those clients, we can make informers and wire up caches and start the reconciler. But of course, the reconciler is not going to do anything. It needs to be invoked somehow, and that's through these listers and informers and the work queue. Okay. I think this is one of the most common questions I bump into, and almost every project gets it wrong. And that is, what is the shape of the status that I need to have? And why does it look like this? So everything needs to have this list of conditions, and inside the list of conditions, it needs to have last transition time, status, type, and everything needs either a ready status or a succeeded status. A ready status is for something that's long-lived, and a succeeded status is for something like a job that runs to completion. And the most important thing is observed generation inside of status. So if we look at a Kubernetes resource, inside the metadata, there's a generation, and generation bumps every time spec or status change. And observed generation tells outside observers for the resource, and maybe I'll show you an example. So if we look at that Knative service, I think it's hello. And we look down here, it has observed generation 2. And if we look at its metadata, it has generation 2. And we made 2 edits, so this makes sense, right? Or maybe, okay, sorry, maybe generation only bumps when spec updates, not status. What that tells us is that a reconciler running in this cluster saw that I made a change to the spec and did some work, and it told me, hey, I did some work. And even if it decided to crash and burn, I need that observed generation to bump because I don't know if the reconciler is running or not. So it's basically, I'm not that religious, but maybe it's like the Catholic booth. You tell your confession, but if you don't know there's someone on the other side, you can't see them, but you need some kind of validation that something happened, and so that's what observed generation is, even if it fails. I think the thing that most people get confused when they're starting out with CRDs and observed generation is that they think observed generation is a shortcut to not do work in the reconciliation. And that is also not true, because every time a resource changes or you need to go and run the reconciliation loop, you need to go and look at everything the state of the world, which might affect what you want to do as a result of the spec of your resource you're reconciling. So observed generation really isn't for the reconciler for this kind, it's for everybody else to believe the status of this thing. So as a resource as a reconciler of another resource that references this thing, I might not believe it unless the generations match. So, right, just ready, succeeded, or ready. Conditions are true, unknown, or false. They have to be strings. The reason for this, if we go back to these like, why isn't it just like a Boolean, or why can't I shorten this down to ready true or something? And the answer is, if they don't have a common shape, and if the simple examples don't look like the complicated examples, I have to make custom clients to interact with all these resources. And if we think about this in the KRM terms, about 50 slides ago, I showed, we expect certain fields in the top level of the resource, and we expect certain shapes inside of status so that we can adopt a contract and then leverage code somewhere else. So I don't need to know what the kind of a resource is. If I'm given its JSON, I can actually understand if it's ready or finished based on the condition set here. And I don't need to know anything else about it. I don't need to understand what all of the other special, configurations readies are, because I know that I'm looking for ready true, and that must be right. It's ready. Yes. There's a question. Mike.
Just to be clear, like who is responsible for updating observed generation? Is it the reconciler or the API server, or?
It is the reconciler.
Yeah.
So for the, I can show you some code in a minute, but basically every reconciliation flow, the pattern that I prefer is that you take your condition set and kind of throw it away, and you do everything. Even if it's an error, before you update status, you update generation. There's always. And that tells other observers that your reconciler did something, or at least attempted to. And even if you don't get to ready or you do fail, your conditions changed because they get recomputed, and observed generation changed, which means I know something happened. So I can trust this status is fresh and it is tied to the generation of the spec. That's above it, if that makes sense.
But why would you update it if you didn't perform any modifying? Like I get what you're saying, that you want to have an acknowledgement, but I guess this means that all other things must, like if this number bumps, then other things are expected to fetch it and check it again, or?
They do, yes. Yeah. So everything that watches it will see that something changed, and it will react to it. And so it's basically the assurance of something happened, some reconciler is alive and attempting to make some progress towards what the spec says. And we take a look at conditions to understand what the resulting action happened to be. So it could be ready false or ready unknown, and there's probably some helpful information if you know a little bit about what is happening in this particular resource. But you don't really need to know, because if let's say you wanted to make a health tool, you could generically look at everything in the cluster, and assuming that it has conditions that are common, right? You're looking for readies or succeededs, and you don't update your dashboard until observed generation matches generation, then now you have a good result of everything is working and everything is running. But if let's say I fail to fully reconcile the next loop, and I don't update generation, I don't know that there's actually something running against that kind, is the problem. That makes sense.
Yep, thanks.
I guess it's like, yeah, there's a bit of how true is this status, and if they're equal, then it must be true. And it might change because everything is dynamic, but if it doesn't match, then it can't be trusted. It's a stale update.
When you find it fits, we can have a break and a cup of coffee, and then we continue.
Oh, a break. Yeah. Okay. One more slide. One more slide, and then.
So you yourself can pause a little bit. Yeah.
Actually, we did this, right? So Knative has several conditions, but there's this one top level ready condition, right? So the first thing I did on Knative was help make a helper package that lets you define things like configurations ready and routes ready, and then based on the status of those subconditions, it updates ready condition. And there's a bit of logic about how data flows between there, but the important part is that based on other observers don't need to understand the configuration ready and routes ready and foo bars ready if there's a ready condition. But you calculate, like you as the developer of the reconciler, compute the ready status based on every subcondition, not necessarily setting ready directly. If you follow. Okay. And then, so next we're going to talk about duck typing, and it's my most favorite topic because it takes the ideas that we've been talking about with CRDs and KRM, and you kind of apply application developer logic to infrastructure code, which is crazy. So we're going to take a quick coffee break and push the coffee button. Maybe do some jumping. No.
Yeah. So everyone in the room, before you leave, make sure that you have talked to Magnus. That is not only the local host, but also a member of the board of SNUS, just like myself here at NetSite. So if you leave now, go by Magnus, or if you leave later, go by Magnus if you have not talked to him earlier, so we can know who has been here. Thank you. So 10-minute break.
Hey, we're coming back. It's a different duck. When does this event end? Okay, great. I probably have, well, I can stretch it as long as you want, but I'll aim for the next 20 minutes and then we can schmooze. You take the mic? Okay, what the heck is duck typing? I will tell you. It's no, sorry. It's you think those are real? No, they're actually wood. So this is duck typing. Okay, so what is duck typing? In languages like Go and I'm sure others, I think Python does this too. So if you compare something like Go to Java, Java will ask you to upfront create the interface that you would like to, narrowly view an instance of some sort of object as if it's this other thing. And then, if you want to make a mammal, you implement animal and so on. And now I can, if I have an instance of a mammal, I can interact with it as if it's an animal and so on. I'm sure you've done this in various things. Go doesn't work that way. Go says, well, if I have an instance of a mammal, can I use it like an animal? Does it so the cute phrase is if it looks like a duck and swims like a duck and quacks like a duck, it's probably duck. And in the computer interface way, it's if it has these methods, then it must be a mammal. So I guess I'll just use it like that, right? And so it's more about creating interfaces for the clients, the consumer side, rather than the provider side. So I, mammal implementer, don't know what narrow contracts the thing that's going to interact with mammals is going to use. So that is a very interesting idea to try to apply to Kubernetes. What? So let's take one more step back. How does this work in REST? Well, you have a base type, and I'm sure if you've interacted with the GitHub API, they're webhooks. Show of hands. Webhooks? No. Okay. Well, shoot. Basically, there's a payload in the JSON there, and there's a field that you can marshal out and look at the type. And then once you know the type, you can go back to the original JSON blob and say, okay, I know that that's a foobar baz. Therefore, I'm going to remarshal it back to the known foobar baz shape, right? And now I get access to everything that I knew about the type. But you can do this for anything, right? And so if we talked about KRM, and it was really important that there are these top-level resources that are structured and well-known, this is why. This is why KRM is interesting, is that I can marshal it as a resource, and because it's just REST, you have a question? Is your mind blown?
I just said 2 comments. 1, now I get it. 2, ducks are not mammals.
Oh, okay, fair
Move
enough.
on.
Yeah, that's fair enough. So, okay, anyway, this concept of duck typing, right? Like you see where this is going. Now I have a REST API, and I can do weird things with it. So, what can we do? Well, right, like the status field has to be in that specific shape, and the unique pieces for things like Knative and everything else that you might write, the unique part was in what the field says, which is why we tend to do value or name thingy, value thingy, versus name value, or right. So it's ready true, rather than well, it's the status name is ready, which is a string, instead of the field name ready, the Boolean true, because now it's really hard to be able to duck type different versions of that thing because they have very different shapes on the outside. And I can't really make a duck type of bespoke nonsense, right? It wouldn't duck. It wouldn't marshal to something that's generic to be able to inspect it, to be able to find out something interesting about it. So, right, okay, so I'm going to walk through 3 examples of instances of duck typing you can find in the Kubernetes ecosystem. And the first one is Cluster API. And I think some people might be aware of Cluster API and what it is, but it's basically an API to make Kubernetes clusters from a Kubernetes cluster. And they have this concept called a provider, and a provider is a reference to something else. And they did it with a couple different hops, but essentially it's, I don't know all of the fields that you need, but I know a few, and so internally Cluster API looks at the your provider object and cherry picks a couple instances or a couple fields that it needs to know about, but you're free to add as many others as you need to make it work for that provider. So this is their what they need minimum contract. There's a project called Kata, which now is a direct competitor to Knative, but they also do kind of interesting scale to 0, scale roll big based on queue depth of things, which is kind of cool. So if you have a consumer reading off a queue, it'd be really nice if the queue didn't have anything in it, that your worker pool goes to 0 or goes to real small. So, and then if there's a whole bunch of things in your message bus, you get a lot more workers. And so they manage this auto scaling worker pool thing based on stuff. And they were asking for advice on how they could have these triggers be more duck typeable. And so they come up with this contract here with this trigger struct, which looks like a Kubernetes resource, right? It has metadata and it has a spec. This with trigger spec is the minimum contract that a trigger needs in its spec to be able for Kata to kind of look at it and understand what it's going to do. And I don't remember exactly what scale triggers is, but it's the point here is that they made a contract, the minimum shape, minimum resource shape, and then they implemented it. Well, you come with something else. Right. So then you can use instances of other things that help Kata understand how you would like the trigger to happen, and that lets the thing that's observing a reference to something else be less tightly coupled to what it's observing, because it doesn't have to worry about the exact scheduled job. It's actually interacting with trigger specs, stuff like that. And then the last one is Knative actually has an eventing project, and the what do I want to say? Okay. So to model an event queue, you have to have a subscriber, and to be able to send an event to something, you have to understand what its network address is. And duck typing came from this desire to have the 2 projects work really well together, but not be totally compiled together. So the first duck was this idea that, well, we're going to get a resource off the Kubernetes API, and we're going to expect it to have an API version and a kind, and then we're going to ignore the spec completely because it doesn't matter to us, and we're going to look for status.address.url, and that's going to be where we're going to send events. And if we bomb out of here and we look here, in fact, that's what happens. There's a status.address.url, and it tells us some. Why are there 2? Oh, I think they changed it. This is the local one, and then the external address is status.url. And this mechanism, if you wanted to integrate with Knative eventing and be a consumer of a subscription, to be resolvable, you would just implement that little shape in your status and magic some RBAC, and you get to play in the ecosystem and I actually will show you an example of this in some code. Right, so if you are skeptical, you are correct, because anyone that's ever done anything with Kubernetes knows that RBAC is a problem, right? So how would I deploy something and then be able to install a new thing and have it interact together? Well, RBAC actually does label selectors if you want. So you can make up a duck type contract in the you can make a role that you can label select on in RBAC to be able to grant the rights of some other controller that was installed in the past to gain access to do whatever you need it to do in the future based on the label selector when the next thing gets installed. Right. So I think maybe we'll do it. I'll take a vote, but I'll show you this other demo. So I have some stuff installed. I have this project on my GitHub. It's newscott/maths, and the idea was that there is. Oh, actually, I have this open. I have two resources I've invented to show some duck typing in action. So here's this silly add resource, and the spec is a list of operations, and a list inside the list of operations is I think it's either or. It's either a reference to something that's a resultable, I think, is the contract. It's not a hard contract because Kubernetes doesn't actually support this. You kind of have to work around the system, or it's a value. And what the heck are you talking about? I'll show you. I'm going to grab it from the README. So I can make something simple like this. I can ruin the. So I'm going to make an add resource. I'm going to make an instance of an add, and in that spec of list of operands, I'm going to say value 1, right? So if I do this right and I run it, right? So I made an add 1, right? That's fine. That's cute. But I can also do things like I can add a few. And so I made custom columns, and it shows you these things. Well, I can also do, and also add, I can subtract a few. I also, copy the wrong thing. I need to add this. So, and then I can reference the two together, which is this one, but I need to modify it because we haven't added the next thing yet, which is what the voting is going to be. So the mixed version is inside my reconciler. This is a silly example, right? But the list of operands is either a value or a reference, and when I reference something, it gives up an expression status that is to make it simple and make it, I assume a reference is a parent something, and that something is a reference to a duck type that is like this. So I made up a duck type called a results type. And so the results type expects type meta and a status. And the status must be in this results shape, which is this, the expression and the ending result, which means I don't really care how it gets represented. I can just cherry pick that and stick it in the parens, and then I can take the integer result and continue doing whatever operations I want to do with this. And so here's the choice. It's 6 o'clock now. We could make a new duck live. I haven't scripted anything for it, and then I can show it being added to this duck typing system, or we could drink beer. Just gonna put it out there, or maybe not beer. Or maybe there's no beer.
There's no beer here. So in
Oh.
that case, we have to go somewhere else.
Aha.
So I think people want to see the duck, the new duck, right? Yes, people are nodding.
Yeah. Okay. All right. Let's do it. And for this next trick, I'm going to use Kube Builder. But hold my not beer yet. I am not super great at Kube Builder because instead I wrote my own reconciliation framework instead of Knative. So we'll see how this goes. But it's going to be fun. Okay. I think where am I? Oh, this is maths. Back to this meetup. I think we should implement mod, right? Something mod, something else. Let's keep it simple because it's ints, right? And what I want is one of these reference things. I want to be able to, oh, maybe die. It needs to have two things. That's more complicated. Oh no, it's, I didn't think about that. It's okay. Well, okay, we won't use references to just keep it simple. We're gonna mod some number mod something else, it comes with a result, and we can reference it back. And I think the clever part is how we're gonna solve the problem of how does without changing what's running in the cluster, how do we allow it to read the result of the new type we're gonna make, right? So let's first just make the mod file. And to show that I don't know what I'm doing, I'm gonna look at the Kube Builder help file. So this is the create a project quick start, and we're gonna read through some of this stuff. No, I swear I know what I'm doing. Don't worry about it. Here we go. I already made the directory, so check. But we don't want to call it my domain. We're gonna. Oh sure, okay, fine. We can call it my domain. Mod. And this is going to do a bunch of nonsense if you've never used Kube Builder. It's also going to set me up with customize and make files. Who likes make files? The door is over there. No. Oh, seriously, the door is over there. No. If you choose a language like Go that's simple to interact with, you don't tend to use a make file because why would you? You just write scripts or you remember how to use the Go tool, and make files, they start out simple and then they turn evil. That's what I'm gonna say. It adds so much complexity to if it's 400 lines long and there's like 50 references, I don't know what happens anymore. And okay, all right, fine. So I like Goland, so don't judge me. I think it's nice. I was an app dev in Java for a long time, so Goland makes it nice for me. I'm gonna totally trust it. No.
The question was whether it's going to give a quick introduction to CoBuild, and the answer is no.
Kube Builder is okay. There were two projects. So I told you that CoreOS coined the term operator as a marketing ploy, right? And so there's also the operator SDK, which was their attempt to provide a framework, but they got purchased by Red Hat, and then the project kind of something interesting happened actually. Kube Builder was Google's internal open source implementation to make CRDs and reconcilers. And those guys talked to the operator SDK people and said, you know what, it's kind of weird that we're both writing like the core foundations. What are you doing? It's because it has a makefile. And they said, wouldn't it be nice if we could both collaborate on that bottom piece, which is now called controller runtime, and we will differentiate each other based on the interactions at the top level, how you get generation and how you actually code the reconciler, how it gets all set up. But the core of how the pieces work and how clients get set up, they started sharing. So they're more or less the same internally, but how you interact with it and the CLIs are different. So Kube Builder is the Google version that's also adopted as a Kubernetes SIG. So I think that you find more examples today of Kube Builder, and it is it's the best 0 to something running experience I can give you. But it doesn't optimize the long-term production value, right? So the day 2 to 5, much harder. And unfortunately, the Knative stuff's not well documented, but it optimized the day 5 stuff and not the day 0 stuff. So it's just harder to bootstrap, but it's much easier to maintain. But we're gonna to do some stuff. Okay. So, oh my goodness, why is there? Okay, we don't need this. Like I said, what is happening? There should be like a, what? It's all in here. Oh, cool. Oh, right, I have to add an API. I forgot. Yeah, here we go. Oh, okay. We're gonna copy that. And we are not gonna run it. So the kind well, let's call it mod. We'll go straight to V1, and web app sounds great. Oh, yes. Please create a controller. Okay, so what this is going to do is it's Kube Builder has some very opinionated ideas around the kind of client that it's going to generate. They basically said, you know what, generation's bad. We're just going to use dynamic clients and not do, because Go doesn't do generics like Java does until recently, to get around how toilsome it is to change the Go structs and then have that generate other code. Then you can use these typed clients. They said, we'll just not do that. And you interact with your resource, and we'll do a bunch of reflection inside and make it feel very easy. And 0 to 1 is a very nice thing. I guess I'm gonna make manifest now. Cool. It's all made now. So all that gave us new stuff. Am I running it in the right directory? Ooh, that would be embarrassing. Yeah. Okay. Okay. Oh, there we go. Just had to load. The API. So we have this new mod types, right? I kind of showed you this on the other side. And there's a helpful thing that says we need to add our stuff here. So we will do that. So if we're going to mod something, we need a base and a, what is it called? Base and a mod. So base int. And then how about a by? I think we have to tell it some JSON stuff. Cool. And we need the status, right? The duck type has to have a result and an expression. Let's just double check. Need that. I should have not closed it, but okay. Oh, it's in this. It's here. So if we remember correctly, if we look at API's duck, just to make sure, the results type looks something like this, and we can actually just steal it. I like stealing. And it inlines into status. So we don't have to take the struct directly, we can just use it, and no one will know. Now I'm going to break a couple rules because this is not for production, and I'm not going to put conditions, and I'm not going to put observed generation because I am a bad person. But this will be okay. Right? Like we won't know if it did it correctly, and so some other external observer is not going to, because I'm not following the generic KRM contract, it won't understand how to generically look at it and understand, this is what happened. But it's okay because we're going to focus on the duck type piece and not this. Okay, so now we need to actually reconcile that. So if we make an instance of that with a base and a by, I think it's in. Everyone use the internal package in Go. Love it. I hate it. It's terrible. It makes it so much more hard to share code around projects. Okay, so here is our mod reconciler, and it's gonna get. KubeBuilder did this control request, and if you look inside here, it's a namespace and a name, right? So remember that key in the funny column? So the work queue spits out this event, and this is what it comes. KubeBuilder just decided to split it for you. All right, my logic goes here. I wonder if I even have a. So I have these mods. And then I inline client. Okay, so I can say r dot. I need to get the object, right? So they also KubeBuilder does this funny thing that I really don't like, and they make it really unclear if you're interacting with the lister or the client. And so I'm going to do this get. But I don't know if it's going to be I can't tell you for sure if it's going to be the client or the listed version from the cache. I don't know because they don't tell me. And I find that really annoying. In the key object, I think it's this request thing. And then object must be the thing I want to hydrate. So I want to make a mod. And these things. I want to make one of these. And then I want to send that down there. What? It's not that. A key. Anybody remember what object key is supposed to be? I'm sure this documentation told me. It's supposed to be namespaced name. Aha, look at this. Oh, it's from an object. Oh. Okay. We have. Okay. Maybe that. What? Well, let's try the. Anyone know how this works? Okay. Oh. see an example. The controller. I don't. I will fumble through this, and then I'll show you why I fumble. Because here we go. This thing is. Here we go. Load it. They want us to do it the right way. So sometimes you get invoked because the thing deleted, and you'll load it, and then it won't be there. You'll throw an error, and then you'll just keep eventing because the thing will re-queue because you threw an error. And the right way to do it is to go and list all the resources that match that thing. And sometimes you get back nothing, and that's okay because it's gone. Yeah. Know how you use your silly little. Here we go. Oh, you can use the namespace name directly. Okay, cool. Then I think this throws an error, but we're trying to make it work. And so every time it reconciles, we're gonna mod what's in the spec, right? So m.spec.base. You would want to check this, right? You would have to make sure that these things aren't null, but we're not going to do that. We're just going to keep on going on. And then we want to have some sort of, so m.status expression. So the expression is the paren thing that we would like other things to be able to display for our equation, but it doesn't need to know how it happened. So the add function is never going to know that we're a mod function. We just know we're going to flow down this. Sorry. So we want to do something like this, but we don't put the result in here. We're just going to put the spec base and spec by. Right, so that gets us our cute equation. Result. Throw this directly in there. Okay, so now we've fulfilled that duck type contract. Every reconciliation will get us a result, and I think if I'm not mistaken, we can make one and see if it. This has a Docker file. I don't think I have Docker installed, so we're gonna have to fix that. Oh yeah, they use customize and some other nonsense. Oof. It's okay. It's okay. We can figure this out. The uncomment the following. Looking for the container. Well, actually, I guess we can use co instead. So. So it's probably going to be in command. It's only one thing, so that makes it easy. We do need to know what the Go mod. I'm sorry, what? My domain, yeah. So co-build, and then we want to say this path. So I showed you co-apply, and it'll look for that co:// and co-build takes the Go binary and turns it into a container and then tells me what it created with the SHA. Oh, while we're waiting, who uses Docker labels, or Docker tags? Oh yeah? You not like knowing what happens in production? So the trouble with Docker labels is that if you change them and you don't have pull always, you never know when it's actually going to run on your nodes, and it terrifies me. It's like the most annoying bug that you end up with. If you don't have pull always, you can't take advantage. You're not allowed to take advantage of caching on the nodes themselves. And then if two nodes want to schedule the same pod, and one pulled one tag and the other pulled the other tag, they'll be running two different containers that just happen to have the same label. And it's just a very frustrating experience to try to figure out what in the world is happening. So here's my new container with my magic code. And then I think I have to slap this in the customize. Maybe in the make file. Image controller latest. What? I swear that might work. I think it will. And then I think I can do like make install to put this whole thing in my cluster. I think that's kind of enough. Run, no, we don't use Docker. Install, yeah, cool. Okay, so now we should be able to create one of those resources and have it be okay. I don't need, but I do need a spec, and I think that was base. So the base will be by, I don't know, 13. Web app mod v1, straight to prod. You know what? Okay, you know what I forgot? I didn't update the status. So I actually have to do it. So at the end here, we actually have to do an update. So the status.update context, because we modified the object, right? And we didn't actually save it, so we have to actually send it. And we're going to send m, which is the thing we edited. And I think that is it. And we'll just swallow the air. And unfortunately, I have to build the container again. So 1 sec. Question? Yes?
So the KO build is basically, does it only work with Go, or is it other languages as well?
It only works with Go, and there's a couple projects out that kind of simulate the experience, but Go has a couple things that make this possible, where I can do cross compilation out of the box with the tool chain, and I end up with a kind of a clean, opaque binary that I can ship around and run. So I'm building on ARM here, and I'm running in AMD in my Kubernetes cluster. That's harder in other languages, but not impossible.
So it's basically running the Go build and then putting in a Scratch container, which is uploads.
It's actually putting it in a chain guard static container
Okay,
as the base, but that's equivalent to distroless.
thank you.
You can change that setting. It'll stick that into a common. There's a contract that Co has, and it'll put it in a specific spot in the file system, and then continue on with the layers. But yeah, this was pretty fast, and most of these things, there's existing blobs, and the existing blob is probably there's a bit of runtime that Go needs, and if your app has other things that it can detect that there's static files or whatever, it'll try to layer them in smart ways and try to reduce the number of layers it has to push, making your builds faster, which is kind of cool. All right, we have to update that make file because I love make files. I suppose you're supposed to like set the environment variable or something, but and because we just I think something worked. Let's see. Why not? It didn't put it in. What the heck is install? Maybe it's deploy or something. Install CRDs. Okay. Deploy. Here we go. Sorry. Okay. The mod file and shows up. Crash loop. I don't mind failing in front of everybody because I think it's actually more interesting to see the struggle and how hard Kubernetes is. And so let's just like check out what's going on. Like get the logs. So let's see what it's saying. Saying nothing. The other thing you can do is describe it, because it'll show you the event streams. Okay, so the other thing that Co does that's really nice is it properly makes the binary manifest, the binary entry point manifest configuration thing according to the OCI spec. I think Customize actually assumes that you binary in some random spot, and that does not match with what Co did. So we have to find where it's making the deployment. We found it, and sure what an RBAC proxy. Yeah, okay. This is the container that it actually runs. And I think all we need to do drop this. It uses our controller that's supposed to come from the makefile, and co does not put the command in that spot. I think this should fix it. Now, running. I think there's one running now. Yeah, okay, so that fixed it, right? The assumption, and if we can double check by looking inside of this wacky Docker file, it does blah blah blah, you know, and it sticks this entry point in the manager. Technically, they don't need to specify that in the manifest inside the deployment because they're writing the entry point here. It's just redundant, just like you're asking for trouble if you're going to define it both places. So just like I did, right? Okay, so now if we look at our mod object, it should have a status. Maybe it reconciled. And it does. So now we want to yeah, who knew? It was 3. Yeah. This is why you need Kubernetes, because this is really hard. So back to the math project. So we look at one of our, the README, yeah. So we made that one. What did we call it? Probably some terrible name. Yeah. We need all this data, and we're gonna just slap it into this mixed one. Name, mod sample, still in the default. It's a mod now. And for fun fact, if you want to watch me fail at doing this exact task, TGIK 145 is where this like piece of the presentation came from, and I forgot to do exactly the same thing as I just went through here because I don't use controller runtime. It's pretty funny. I need the and we're going to create this, and it's going to fail because we haven't updated RBAC and we haven't done so. So we're gonna do it, and the maths add reconciler is going to complain at us, and then we'll fix it. Right? It's crashing. So new observed generation failure is actually a Knative reconciler problem. And what's happened is it's gotten to the point where it's trying to resolve the reference and turn it into the duck type, and it gets an RBAC error. If I looked at the logs or I looked at some events, it'll actually, well, I can show you, I can prove it. I describe it. Right, so I don't have the right to read that resource as one of the internal events that popped out at the bottom, which makes sense because we described that. And I go back to the maths. I'll show you. We're going to pop this window. Probably a mistake, but YOLO, here we go. So the way this works inside of the maths project is a special results viewer cluster role, which is the label selector thing that I was talking about. So it has to be something, right? You make it up. And what I picked was a duck.tableflip.dev, which is a domain I own because I'm funny. And it has to, it has to be something. So it's equals true. It's just a string. There's no Boolean there. It's just a thing that some other thing is going to do it's going to, the cluster role manager, like the Kubernetes concept, is watching for cluster roles. And one of the filters it has on is this label selector, because down here in the cluster, looking for the role binding, the piece that actually connects the two. Here's the cluster role, right? Okay, yeah, so this cluster role results viewer matches every role that has this duck.tableflip.dev results. And one of them is this. So we're going to copy this. Sorry if you are getting flash fatigue. But we still need a cluster role. It needs to be a unique name because it's our thing. It needs to have this label on it, or otherwise the whole system doesn't work. It needs the API group. This is a mod now, mod status. And sure, it can get list and watch them. This is wrong. What was it, like web something? Oh, it's here. Sorry, a little sensitive about the version. Okay, so our new thing, we're going to make this role and we're going to apply it to the cluster, and we might have to touch the resource to make the reconciler do something. So here we can called mixed. Right, so reconciliation hasn't happened. And if we wait 10 hours, if you don't mind, we're probably nearly there. Or we can do a trick where we modify its labels. So if we come in here and this is a trick if you're kind of like trying to figure out why this thing's not working. The big hammer is delete the reconciler and it'll come back, right? Because it's a deployment. And so if you delete the pod, it'll reschedule and come back and redo everything. That's the big hammer. The little hammer is you come in here and you just add a label. Oh, happened. Holy, that's good. What do you want? Mixed was not valid. Invalid value. I disagree. It's a valid value. Oh, thank you. Thank you. Let's do the describe thing again. Forbidden user. At the cluster scope. Ooh. Maybe we got our. Oh, okay. That's right. Oh. Okay, but worked first try. So, you know the difference between kind and resource? Pain. It's pain. you know, somebody decided that the best way to distinguish between groups of things and an individual is to rely on English pluralization, which just makes everyone sad all the time. And so a resource is the plural version of a kind, but that the rules, there's actually a helper method in API machinery that's best guessed to plural or something like that. And it takes the kind and it just tries to add an S or an ES or S's or, and it's the worst. But here we go. So the math add reconciler references this thing and it doesn't really understand what it is, but because we implemented this common shape, we can pull in this opaque string with the results and we can add to the extra piece of result and we get an answer, and we've extended the system to be this new thing. And why did I show you all this? It's because, you know, the ideas of duck typing and references and being able to interact with objects like cluster API in the common shape that you care about, you can start writing, you know, the first step is to write tools that consume duck type shaped things and displays something for you. So you can, if you know that everything has your conditions in status and it has a ready condition, well, you can make a tool that scrapes all that stuff in the cluster and tells you what's ready and what's not. You don't even have to know what the kinds are. You could display it, but the kind isn't important. The RBAC is, but the kind isn't. And so I've built all sorts of fun things. Actually, I work. There's a crazy project inside my GitHub called Sugar Reconciler, and it was a reconciler doing things like. Actually, I showed you Knative, right? Knative is cool, but I said, you know what, the better pattern is to actually use domain mapping. And I had this idea is, well, what if you could annotate or label a Knative service, or really anything that's addressable, let's just the Knative service, and based on the annotation, we could create a domain map, but that actually works with anything that is routable. So add this magic label, and then out comes a domain map that gets managed by and tied to the lifecycle of the resource it came from. Because now I'm a controller and I can programmatically assign the ownership pattern and point to the other service. And so if I delete that service, the domain mapping auto gets deleted. And so this idea of could I reconcile things that are of a shape that I care about, but I don't care about the kind, assuming I can fix the RBAC problem, then I can start writing reconcilers that reconcile duck types indirectly, which was kind of cool. So I hope that inspires you to think about how you might apply this to things you're doing inside of Kubernetes. And I hope I threaded all of that together with the ideas of KRM. It's just an API server. And if you start from it's just an API server, what can you do? What can you build? So that's what I have, and thanks for listening.
Any last questions to Scott?
Thanks. I learned a lot today. Maybe more your comment and a question. Have the CRD kids gone too damn far? Is everything too custom? Like, what has Kubernetes become if just a monster of third-party CRDs and boilerplate code? And
so I think that the interesting answer is if it helps them get stuff done, then it's probably not a problem because they're using Kubernetes as a platform to build a platform to do other work. And I think that's a cool idea. And where we can continue going there is if I could somehow convince you to implement other ducks that let my thing that I'm building in my cloister interact with your cloister objects, the world gets really interesting, right? Like, let's say I know you deploy an application and I wrote an operator to go and manage the lifecycle and creating all of the nonsense resources that you need. Sorry, not nonsense. They're very valid. But where we get stuck is I don't know how to find your URL, right? So now I have to assume that it's the service that has a special name. But if you have an object that is, if you implemented addressable in the top level ask of installing my microservice, you know, your custom microservice, and in the status was status.url, well, now it's really simple. I can double check that it has the correct generation. I can check that it's ready, and then I can know where to find it on the local cluster. So it's kind of, it helps me solve the service discovery, and more importantly, I can write a thing that injects your address into my application or my pod's template, and I get self-healing as things are dynamically changing in the system. Now the system gets really interesting. And so are we going too far with CRDs? Maybe, but I think yet only because they don't interplay so much anymore. They don't yet interplay, because these ideas around duck typing and common shapes and KRM, I don't know if I made the point strong enough, but you know, if the KRM can exist off of the cluster as long as I fulfill the contract that is represented by the resource. So now I can also do duck typing things off of the cluster, which could be really fun. Does that kind of answer?
Yes.
So do better, my answer.
Anything else? But in that case, I think Magnus and myself, as board members of SNUS, thank you for coming. And I hope this was valuable. And the next session seems to be one about a DNS resolver project called Tapir. That is to talk about more robust resolver services. DNS resolver server. We'll come back with information about that to members of Soft SNUS and ISOC SE. And thank you very much to NetInsight for providing this room. This is the first time I'm here in this room, and I will definitely ask to be able to come back.
Yeah, this is a super great.
It's a pleasure to have you. And since we use this on regular basis, I knew it would kind of solve the problems you were seeking to resolve quickly. And I don't need an expert for this room, so.
Okay, once again, thank you, Scott and Martin, for coming. Thank you.